How often you felt frustrated while you were developing a feature or you were debugging a production bug on a Kubernetes platform due to its prolonged feedback time? Did you feel the entire process being slow and you end up learning many tools than the most familiar ones you always were using for your local development? If your answer to all of above is yes, then this video is for you. Hello, I am Sanjit and welcome to my channel. Let's get started and see how to accelerate development of Kubernetes applications. Let me start first with the context, the why. Existing Kubernetes app development is slow. To understand why, I would like to talk about the inner loop and the outer loop, which was first coined by this guy from Microsoft, Mitch Tenney. Cloud native technologies has fundamentally altered the developer experience. Not only are engineers expected to design and build service-based applications, but they now also have to manage external dependencies, build containers, and implement orchestration configurations such as Kubernetes manifest YAML files. This may appear trivial at first, but this has a large impact on development time. As you could see, the inner loop is the iterative process of writing, building, and debugging code that a single developer performs before sharing the code with the team. The inner loop is where the actual work is done by the developers. The outer dev loop starts as soon as your code is checked into the version control. This is where you hand over the most of the responsibilities to automated systems, CI/CD pipelines, to do the job as per a typical gitops workflow. As you would have already guessed, inner dev loop is the most critical of both. This is where a rapid and continuous feedback loop really helps debugging issues, making changes, and immediately seeing the output. But unfortunately, today, our inner dev loop is not the one we really aspire for. Let's now talk about one of the many other solutions available in the industry which is trying to address such concerns: Telepresence. Telepresence is an open source tool that let developers code and test microservices locally against a remote Kubernetes cluster. It runs code locally and forward requests to and from the cluster, bypassing the much slower process of waiting for a container to build, pushing it to the registry, and deploying onto your cluster. Open source Telepresence is licensed under Apache 2.0. It's a CNCF project. It is created by Ambassador team, formerly DataWire. Let's now talk about Telepresence value propositions. Debug locally. With Telepresence, you can debug your Kubernetes service locally using your favorite debugging tool. Instant feedback. With Telepresence, you can test and iterate on your code changes instantly instead of waiting for your deployment cycle. Realistic environment. How often do we hear about bugs seen in production but not being able to reproduce in local environment? With Telepresence, you are developing on a Kubernetes cluster, which can be configured to be identical to your production. This eliminates bugs due to differences between development and production. Minimal resource footprint. Telepresence adds virtually zero overhead to your development environment. It only requires the memory and CPU necessary to run your services. Use your own tools. With Telepresence, you can use your favorite code editor, debugger, profiler, or any other tools. Anything that runs on your laptop works with Telepresence. Let us now see things in action. We will use this demo UI emoji vote to show telepresence in action. This UI shows a list of emojis and lets you to vote for your favorite emoji. We will first see the existing gitops workflow, taking Google Cloud Platform as an example. Developer first makes a change based on a requirement and pushes these changes to GitHub repo. This then triggers the GCP gitops workflow. The cloud source repository will sync from GitHub and then triggers the cloud build CI/CD pipeline. The cloud build will do two things. First, it pushes the new image to Google Artifact Registry post the successful build. Secondly, it will trigger the CD process by deploying the new image in the environment which is based out of Kubernetes engine. As you could see, the application consists of three microservices. Web microservice, responsible for the user interface. Emoji microservice, responsible for listing the emojis. And voting microservice, responsible for allowing users to vote. In the first use case, we will see the time taken to implement a new feature using the traditional GitOps workflow in Google Kubernetes engine. Let us start by first exploring the existing emoji vote user interface. As you could see, it is showing a list of emojis and the number of votes for each of them. You also have an option to vote for your favorite ones. For our new requirement, we will consider a hypothetical scenario to add India flag emoji in our user interface. We first start by making the necessary code changes. I have first forwarded the video here as it's not much of concern for the scope of this topic. Post the code changes, we will compile, build, test, and then push our changes to a version control. This will trigger the gitops workflow. Here on, we will start tracking the time. As you could see, the build is auto-triggered. The new images containing our changes are pushed to Google Artifact Registry, and the deployments restarted in our Kubernetes environment. The artifact registry now has the latest images. And deployment of Kubernetes manifest with new images has started in GKE. We are now in Kubernetes engine dashboard. Here we need to now wait for our new pod instances to come up. All our pods are up and running now. And now we see the India flag in our UI. Overall feedback time is approximately 9 minutes. Let us now see the same use case but with telepresence. Like before, we will start first by making the necessary code changes. In the next step, we will connect Telepresence to our remote Kubernetes cluster, and we will do this by Telepresence connect command. As you could see, Telepresence is now successfully connected to our remote GKE cluster. And Telepresence list shows our three microservices: emoji, voting, and web. In the current UI, there is no India flag. Let us intercept the emoji microservice because our changes are in this service. This will inject a traffic agent sidecar container into the workloads pod. Post the interception, we will run our emoji applications locally right in our IDE. Ensure that the local emoji service is listening exactly at the same port that you have used in your telepresence intercept command. In this case, we have used 8020 port. Let's refresh the UI. India flag is now visible. Overall feedback time now with telepresence is just 3 minutes. Now let's see how easily we can debug a Kubernetes application using telepresence. We will start with the usual way of connecting telepresence to our remote Kubernetes cluster, followed by intercepting the microservice which has the issue. In this case, it's the voting microservice. Let's now run the voting service locally and make sure it's listening at the port which is configured in the telepresence intercept command. As the service is now running, let's kick in the workflow. As you could see, we hit the breakpoint. We can now investigate the variables like we always do when we are testing things locally right in our IDE. Cool, isn't it? That's all I had to share about telepresence in this video. I hope you liked it as much as I did while making this. Thank you for watching.